Hey all, this is a quarantine science lab. Quarantine science lab rehearsal. What is this? An alert on my phone. This is a rehearsal for quarantine science lab. Do 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 do. Okay, there's our intro. All right, so I am running through an experiment that I did it with Marie, but we're going to do it a little differently this time, and I think it's going to be way cooler. So Marie is learning how to use a breadboard. I have a breadboard with 5.5 volts. That's your standard USB voltage. I have a small compass here. I have a switch. It's just a touch switch. Okay. And I have a wire coil. It's actually an inductor. So what I'm trying to teach the kids here is, I also have this this piece of film, plastic film that is magnetic. I don't know what it's called. It displays a magnetic field in the film when you pass a magnetic field near it. So you're about to see that. What I'm trying to get across here is that whenever you have electricity passing through a wire, you have a magnetic field around the wire. And when you have a coil like this, it's called an inductor, but it's just a coil of wire. I made this myself. You don't have to go buy one, you can just make one. When you have an inductor and you run electricity through it, run a voltage through it, what happens is that the voltage is slowed down, the current is slowed down as it goes through the inductor, and a magnetic field builds around the inductor. And only after that magnetic field is fully constructed or inflated, whatever you want to call it, then the current starts to flow at its normal pace. When you remove the power source, then the magnetic field collapses like a balloon when you let it go in the air, and it pushes electricity through the wires really fast. But we're not going to be jumping any spark gaps today with this. We're just going to be looking at the magnetic field around the inductor. So I'll show you what I mean. Hope you can see it. That's why I'm doing this test. This is a pretty inexpensive power supply on a pretty inexpensive breadboard. It has 4 prongs. They go into both sides, and when you turn it on, it puts 5.5 volts, or what is it? 3.3 volts or 5 volts into the breadboard rails. So, Derek, do less. So this is going to be a super simple circuit. I am just going to connect the power rail here to one side of the switch. I'm going to connect the inductor to the other side of the switch. I'm going to connect the other side of the inductor to the ground rail. Okay, now this is where the cool stuff starts. So I put my compass here, turn this on. Now, this magnetic field around this inductor should make the compass deviate. Unfortunately, I have it on the north side, so let's move it. I don't know if you can see the compass deviating. It's deviating a lot right now. Let's try and get that. Can you see the compass? It's pointing directly this way. And when I hit the switch, it deviates. Deviates about 15 degrees. Okay, now we're going to try something else here. Hey, what are you doing? What are you doing? Oh, that's a good girl. I'm filming. I'm filming. Do you want to be in the film? Huh? No, I didn't think so. So here's our magnetic film. I'm just going to hit the switch and let's see what happens. Nothing there. Okay, hang on. Hey, sweetie. I know, it's a red leaf. You want to show everybody? What kind of leaf is it?
It is from fall. It is from fall.
It is from fall. Put this on. For some reason this is not working. I'm really surprised. I thought that this would really... Well, that's really disappointing. Well, I was already disappointed with this film, but now I'm even more disappointed. Nothing. I don't see anything. Marie, can you go grab me one of your magnets from the... Yeah, that's a little breadboard. Are you... Don't pull those out. Okay. Don't lose them. Those are germanium diodes. Hang on. Hang on. Now you're all excited. Before you didn't want to come over here because you wanted to play Fortnite. Look at Marie playing with her breadboard. Show everybody your breadboard.
It's a tiny one.
It's a tiny one. But this is yours too. Yeah. All right, let's show everybody what happens. What do you think is going to happen when we put this compass here? I wish I had set this up differently. You know what? Let's rearrange it.
Oh, I want to try. Is it going to move or not?
Yeah. Wow, that really deviated a lot.
Ooh,
this is the position we need to be in. Look at that.
This is a better button.
Hmm?
That's a better button.
It's a better button?
It's better than the other one. What's this?
Should we just go right into our... That's a trimmer. That changes the current as it goes through there. That's a voltage display. That's the same button we have here without a cap on it. That's not going to go in all the way, so be careful. If you press too hard, it might break. You know what we can do, Marie? Let's move this over here. Instead of using the rails that get in our way here, let's use the rails that are over here. Let's move this. What happened?
Baking.
You want to go right into our demo, Marie? Should we go right into our science lab? Or should we? Okay, that's good, yeah. Tell you what we'll do. Almost. We need something to prop this on. It's not staying there. What? Oh, okay. They're looking at you working on your breadboard. That's pretty cool what you're doing there. But you don't have any power over there.
I need to copy yours.
No. Or you could just work on this one. Let's bring the viewers back over where we're working over here. All right, you ready? What's going to happen, Marie, when we put... What's going to happen when we put current through that inductor right there? Which way is the magnet pointing? Hey. Do you want to do our episode right now?
I can't find any of these little ones.
Yeah, wait. Tell you what, let's work on this video and why don't you introduce, Marie, why don't you introduce Quarantine Science Lab? Show everybody your lab coat. Say. The other side. Say, welcome to Quarantine Science Lab. All right. All right, sweetie. Let's do this episode, okay? Marie, what's going to happen? Which way is the compass pointing? Put your hand over here and show everybody which way. Good. North is which way?
N.
Yeah. So point. Show everybody which way it's pointing. That's correct. Wait, give me your hand. Point. Yeah, let's bring it into view. Perfect. Now, go ahead and press the button so everybody can see.
It's not moving. Just a little.
All right, just a minute. Let's do this then. All right, hang on. Can everybody see it? All right, now do it, Marie. Now press the button. Wow, that's a big deviation. That's about 15 degrees. What's interesting is that we only ever get about 15 degrees of deviation. Why do you think that's happening, Marie? Whenever you pass electricity through a wire, there's a magnetic field created around the wire, right? Do you know what the waterfall, the water flow analogy for electricity is, Marie? You're grabbing resistors out of that big pack. What are you going to do with the resistors?
I'm looking at them.
Yeah, you're looking at them.
Joy wants them in there.
Do you remember we learned how to read we learned what a schematic drawing is?
No.
Hey, let's film an intro. Wait, don't. Don't. Let's film an intro. You ready?
But how can I do this?
Hey, this is Dave and Miss Marie.
Hey.
Marie, say hi. And you're watching Quarantine Science Lab. Thank you.
That's from Harpoon Dreams.
No, not Harpoon Dreams. Quarantine Science Lab. Careful, don't fall. Quarantine Science Lab. Marie got confused between Harpoon Dreams and Quarantine Science Lab. Those are our two podcasts. All right, Marie. So we've already shown people what this does. You want to show them one more time? Let's show them one more. No, no, no. Don't take that. Guess what? It's broken. But it's okay. I can fix it. But now, no more quarantine science lab episode because it's broken now. You pulled the leg off. Look. See that? Now I have to solder it again. You can't do anything with it. It's broken. So, okay. We'll make a new one. Is there electricity running through those wires, Marie? Show us over here. Put it over here.
I need that.
Here, okay, here. Put it in. Go ahead. Put it in there. And then put this over here and show people what doesn't happen. Show everybody what doesn't happen. You did a really good job of copying the circuit I made, except for one important thing. What is the one important thing that's missing? Well, besides that one being broken. What's the one supremely important thing that's missing? Is it a fall leaf or is it a power supply? Power supply, very good. All right, say goodnight. Say goodnight.
Good night.
All right. Good night. Thanks for watching Quarantine Science Lab. Have a good one. Let's tag Mommy, right? Let's tag Mommy.
Ew.
How come Mommy? I don't see Mommy here. Mommy's not